Alright boys, so I was going through YouTube, randomly watching videos and stuff, and I stumbled across this. This totally brought my interest and passion for this idea of creating a self-driving kayak fully back to life. I just want to go through and show this guy pulled it off. He goes 12 miles per hour. He says on his GoFundMe page that he actually can go 20 miles with this thing, and that's way further than I'll need just for river trips where people aren't using it. I'm paddling with them. The idea here is I want to be able to go kayaking without having to do much paddling in the flat water and whatever, and this will just make it so much easier, especially since I don't kayak that much. And so if I'm with people that kayak a lot more, I'll be able to catch up with them a lot easier. Same thing with my dad. In fact, that'll enable my dad to do more kayaking um, later in life after his body starts just getting tired easier. And same thing for me and my wife. I mean, you name it, even my kids. This allows lazy old people to keep up with the teens or whatever so easily. So check this out. This guy uses a brushless DC motor, the same kind I'm using for my robot, to directly connect to a propeller blade. Usually it's a fiberglass reinforced propeller. He's also tried aluminum propeller, which he had built for him by a machine that carves it, a CNC machine that actually drilled it out of a block of aluminum, but you could probably do cast aluminum as well, or even maybe welded, but that would be much less reliable. Um, I think really the best is a composite style with fiberglass and epoxy. Um, but I'm going to have to look at my original designs, reviewing that for how I plan to do this. But the idea would be if rocks are coming, the blades would fold up, and it would have some type of detection mechanism, maybe some kind of antennas or something that can feel beneath it. If it feels a rock coming, the blades immediately fold up, and then they're just spinning like this. And then it could loosen up the connection so that the the whole thing's just loose. And so it's spinning still because of the momentum, but the blades aren't sticking out, so they're not going to catch on anything. They're just spinning like in a little cluster, and they're loose in the water, so they can just flop around. So basically, when the rock hits it, they'll just bounce without actually breaking anything. That's the key, to have it be able to quickly engage into a mode where it's not going to immediately shatter upon impact, because rocks are going to be a big issue. Now this guy has built his on a sea kayak to use for lakes and fishing, but mine's going to be more so for whitewater. And also, he did create a steering system that turns it left and right, and that's where the AI could come in. You could put cameras on the front of your boat, and then the AI could actually steer you. And so that would be really fun for whitewater. Alright, so check this out.
Let's run them. Is every kayak's can a small motor.
Alright, so this whole video, he just shows like his mounting setup, which is really primitive, and he doesn't even show the motors or anything on this video. So this video actually had me kind of scratching my head. It was definitely inspiring to see the results, but he didn't show much of what's going on. But I found a video where he gets into detail with it, which is really nice.
It can completely right hour between the. I mean, in the description plate we're gonna.
So basically, his just right now, can lift up down
a little bit,
on this hinge,
a little bit. Now I'm thinking about putting on a second one down there. Call the bolt wrong.
But he doesn't even show the motor on the video.
To come in.
See, it just flips
right
up.
Here. Turns out have anyone.
And then he just shows more so the testing.
Just so I can. I'm okay.
It's a 200 amp.
This works just.
That's the speed controller, and then he uses a water pump from a car to cool it.
It's fine.
That's actually to cool the speed controller.
In the bottom. No. This. That's for supply. Let's get back to the.
That's his remote for it, by the way. That's hilarious. This is how he can actually steer forward, back, and turn his kayak all by remote. Whereas I would need something where I'm able to maybe have a brake and gas pedal that I use with my right foot, maybe, and then for steering, maybe something could be built uh, that tracks like if a camera were to face my body, then that camera would be able to see the kayaker like leaning their head, and it would steer like based on your head. So you could like turn your head and shoulders, and a vision algorithm built into this camera would be able to detect what you're doing with your body and steer accordingly. Although front-facing cameras would be able to see what you're doing as well, and what you're trying to avoid and whatever. And so artificial intelligence could put together all the clues and maybe see what you're doing with your paddle as well, to be able to determine based on a lot of clues what you're trying to do. So basically it would read your mind based on body language and all the clues involved. It would be able to steer intuitively through technology and algorithms. Um, and it's pretty much same thing with speed to some extent, but I think it'd be kind of cool to have a brake and a gas pedal to make it a little more manual on the speed and stopping, because you may prefer just to paddle for a while without its help, and then you might want to engage it to like speed up quickly, and it might not know you're wanting to do that. So for that aspect, I would probably want it to be like that. But the steering would be hard to implement without something where you could like tilt your head for it to know or something like that. Because it's like your hands are taken up and your feet are taken up just trying to brace yourself. It's already going to be hard enough to use a foot to stop and go. So that will require some trial and error to figure out what works best.
Super assuming you're.
But eventually you would want to be able to program the boat to actually run rapids and stuff all automatically based on GPS and landmarks and stuff. It would be able to actually navigate using sensors and whatnot. Same type of technology as self-driving cars, really.
Control.
And you could actually set up the pathing and the GPS using a drone in advance. You could actually take a drone trip, marking out the GPS coordinates, creating like a plot of everything that needs to be done, and then run the test with nobody in the boat. Just have the boat go down each rapid, and then eventually you'd be ready then to sit in the boat and have the boat just take you down the trip. You wouldn't even have to paddle necessarily. But you would paddle just to help with like bracing and speed and whatever. But it would be a combination of your skill plus the boat's skill combined would take you to a new level, I feel.
This close, just hit it.
But theoretically, the boat could do it all, even without you helping, if you really dialed it in. But I feel like I would still want to take part too, so that my skills don't get rusty while I'm out there. So I would probably like have the boat just assist me like 20 or 30%, just to take me to a new level, I think.
How's it gonna work?
But even just like standing on the shore and just doing tests with like just the boat doing all the work would be pretty fun.
And that was as long as it's just of the best time ever. Or no, we're just low on it, but really so.
He shows how fast
Cool
it can go.
This
I
is
mean,
how
it's
it was
fast.
designed into half.
Let's see.
So it's the
I
ground.
mean, it doesn't even need to be that fast for what I want to do.
Have been in there just
It's like overkill.
steering is cut.
Let's see.
Absolutely. Let's get back.
That would be super cool. Imagine whitewater kayaking and that thing's just zooming you. You would be able to get such speed, and then if it's able to turn intuitively and get you where you need to be and help you ferrying and stuff. I mean, this is going to make whitewater kayaking even so much easier.
So,
But don't get me wrong, like this would be fun just on lakes too. And flat water kayaking just on regular rivers too.
And get out. See it.
Look at it's even making a huge wake. Like, this is super cool.
Many people.
Alright, so that got me super stoked. And then I found, let's see.
So this is the rudder system.
Alright, so he's got a rotor system.
And it has...
That, I think, came with the boat. Yeah, that for sure came with the boat, as far as the rotor. For whitewater, I don't think you'd need a rotor. You would be doing the rotoring with your own paddle. Yeah, all the rotoring I would do manual. But actually just turning the motor, just being able to pivot it, would actually turn you. So this would not be necessary at all. But this was built into his wife's boat. He's doing his wife's boat now. He uses a twin motor designed for her boat.
Has this little line right. I thought not put money around that place because it's pushing against.
Alright, so he just creates a vertical piece of aluminum, and then he puts like a T on the bottom, and then has the motor stick out the bottom sides of it. Yeah, you can see it here. So that's the vertical thing he just showed. Here's the T. That's where the two motors are going to go. So my design would have this thing able to turn left and right, and also able to flip around and mount itself on the top of the kayak, but maybe that all that is not even necessary, but maybe it is. I'm not sure, because he's not dealing with rocks. So I would need mine to be able to bend here if it needs to flip upward. So I don't know. His first design was actually a little better for something like whitewater, to lift it out of the water quickly on an as-needed basis. But oh, okay, he used the twin motor design because the rudder was in the way. Otherwise, he'd just use a center motor. Okay, I got it. But yeah, I don't think two motors is necessary, really. Unless if it's this type of case, because he's trying to straddle that center thing. But look, this is the same type of motors we already bought for the robot. So that's pretty cool. And these are totally waterproof motors too. But he was showing that sand gets in them, and then they start getting all crusty. So he's going to try to solve that in another video he's doing. See, here is the milled aluminum version that he got. But he didn't like the angles of the blades, so he's going to end up 3D printing with this 3D printer a bunch of different designs for the angles of the blades. So that's where I got.
This is
so that's the Hobie twin motor kayak build. And now this video is where I'm at now.
put together in 18.6. Expensive. Since on this, I probably that's there if you want to see. No, so that bearing coated in the CRC Molly loop in underwater. But I said if this is sand, 18-foot deep water. So no matter what,
you got a lot of sand in there. I don't like
clean
that.
it all up. You can just take these things in here. Extra cool for supplying.
So he decides that he's going to try to create some type of system where the motor's not in the water, but it translates that turning to the blades that are in the water. And that was my original design that I already had planned for my self-driving kayak project. And this, what I'm recording right now, is video 2 of my self-driving kayak project because it's further development of ideas and stuff. So this is more so just a proof of concept. It just shows that my idea is going to work. It shows a guy that's actually done much more progress than I have in this area, and I can definitely learn things from his journey. So I just wanted to show it. This video has a lot about his build. He goes into a lot of the problems he's run into, and he shows really excellent new design for the blade. And he's talking about this thing being used to I think turn the propeller left and right. He's showing different types of blades, and he also shows this really cool battery system that he found, which which is made for, what do you say?
Right now they're showing this will pop off, the whole system shuts down, you're fine, boat stays close to you, kind of just like a jet ski when you fall off a jet ski. Let's talk about power right here. This is an awesome battery. These are from batteryhookup.com, and right now they're showing sold out on their website. But don't worry, guys, they've got them. And they also have a bunch of other batteries, too. So this is one of the packs we're going to build. This is the SPIM08HP. These batteries were for buses in China, inner city buses, and they were going to essentially power electric buses. This LiPo cell right here is capable of dumping 200 amps safely, all the way down to its minimum capacity. So that is a beast. The other cool thing about these batteries, and I know a lot of guys are saying...
So yeah, he's just talking about this battery. He's saying he really likes it. So anyways, just very cool. This can go in the back of your kayak, and he's actually trying to put enough batteries in there to go 20 miles in flat water. That's way overkill for whitewater application. I would say for whitewater, maybe like the whole entire thing would be 20 miles. And then the flat water portions where you'd use it might be, I mean, it depends how lazy you want to be and how much you want to use it in the actual whitewater too. And then all the other equipment to do like the processing, the algorithms, the vision. I mean, maybe I would want the same amount of batteries as what he's using just to play it safe, but maybe cut it in half though. 10 miles worth of stuff would probably be fine. Because I mean, it's not going to be like working as hard in the whitewater as it would just going for miles and miles in a lake. I don't think. But it depends how fast he's talking about when he says 20 miles tested. He might be going only 5 miles an hour, and I might actually use it like kind of on that type of level for the whitewater. And it's not like it's all rapids. There's a decent amount of flat water in between. So yeah, I might get spoiled and use it more and more in whitewater just because it's going to be really fun, I think. It's going to make whitewater kayaking way funner, I believe. Because you're going to be just flying through these rapids like and have so much more control. It's just going to be really cool, I feel.
LiPos are dangerous. Battery. I've seen the video. Really,
Not to mention, like, the boat assisting you is just going to make it way easier. So you can do, like, harder rivers and just have, like, no limits on where you can go, pretty much. It'll just make the sport so much easier.
But by pulling all this stuff, building modules...
And more fun. Like, to attain upstream takes so much effort. With this, you would be able to attain so easily. Oh, just everything is going to be so much easier.
And I want this to be my... I think we're spot welding what we were going to do over and then up all the cool air from...
I have a feeling once you start using, like, this type of technology, you're not going to want to do whitewater kayaking without it. It's just going to be boring compared to this. This will make it so much better. And being the only person having it will be even more cool because everyone in your group is going to be, like, tired and you're going to have full of energy and not be so sore. I mean, you can still paddle and stuff, but you'll be able to, for example, like, you can play boat and surf way more, and the groups moved on, they're, like, going through the flat water portion, and then you can, like, zoom out there and just catch up very easily. And so you'll be able to spend more time surfing while they're out paddling their butts off, like, getting through the flat water stuff. So you'll be able to spend more energy doing the things you prefer to do. Also, let's say you want to surf a hole, but you miss it, and that happens all the time. You don't drop into it in time and you just get swept downstream. With this, you'd be able to just turn on your motor and zoom upstream and get back to the hole you missed that you saw out of the corner of your eye a little too late. You'll be able to actually boat upstream through the current, get to the hole you want to get to, and then surf in it. That's super cool to me.
From that Mr. Cool unit and holding on, we're good to go, right? And that'll just be, we don't want... So when super cooling, the other side is going to get down to a little... Or things here that works for us to help remove that.
Wow, he's using those?
This is a switch that will automatically... It's going to ton of power. Following this is going to take a big battery. Like when you hit and remove the heat from the system, then we're that we don't need. Using XT6. I remember, I want to show you this. I'm going to grab onto this, and I'm going to put pressure on it. I want you to see how much pressure I'm putting on it. You can see I can't keep it. I end up using it. Okay? Sure, it's pretty awesome. Actually, it was a little too much. What's going on right now? I went through at 7 miles an hour. The 250 pound guy in the boat. I'm at 8 miles an hour. I'll push it a little bit. If this thing can't handle 8 miles an hour, 65 amps, and 3,000 watts.
That is so cool, man. This is gonna be this is gonna make kayaking way more fun. Oh, I can't wait to build this stuff. It's gonna be so cool. So yeah, definitely, like, rather than write this stuff in my notes, I just decided to do a video. This will be part 2 of my self-driving kayak series. Definitely gonna be using the things I learned from this guy. Just a quick update for the self-driving kayak project video. Um, the guy was talking about sand getting in his motor. It's supposed to be a sealed motor, and he said sand was getting in. Well, the first motor he bought was not sealed. The second one he bought is fully sealed. So basically, you just have to make sure you're getting a motor that's properly sealed, and if it is, no sand will get in, and you actually can put the motor in the water fully, and not have to create some type of transmission system that transfers the power from the motor to the propeller, which actually makes the design way easier to implement. And so I'll probably go with motor and water now that I've seen how excellent it is. Then it's just a matter of setting up the system that holds that motor into place and turns it and whatnot and designing that out. But actually putting the motor in the water is a huge advantage if you can get away with it. And it's proven here that you can get away with it. So that's good to know, and